Okay, so let's move on to section 13.2, where we introduce a new rule. Our previous rule was under the heading using the universal quantifier, as in if you have a universal quantifier, here's a rule that allows you to infer something that does not have a universal quantifier out front. Now we're going to get a rule for showing an existential quantifier, as in if you have no existential quantifiers, here's a rule that allows you to get one. So it doesn't really matter what our interpretation of the predicates and names are. This will be valid no matter how we interpret it, but this looks an awful lot like one we've seen before, and this is the one from the text. So all humans are mortal. Aristotle is human. Therefore, someone is mortal. Assuming our domain of discourse is humans, we could say someone. If it's larger than that, we could say some object or something. But let's assume we're talking about, well, if we've made our domain of discourse humans, then this predicate would be unnecessary. So let's make it like all beings or something like that. Then we'd have to say, well, then something, some being, human or otherwise, some being is mortal. Okay, but let's just prove it using our rules. We already have a rule that says if we know a quantifier, a universally quantified statement is true, then we can remove the quantifier and replace all of the previously bound variables with any term. In this case, we'll choose the name Aristotle, and we will justify that. One universal instantiation or universal elimination. Then we can get the conclusion, therefore, Aristotle must be mortal. 2, 3, modus ponens, or now we might call this. How do we get from here to here, and why should we be able to get to? The point is we're going to introduce a rule. We're starting with an example. Why should we be able to move from here to here? What we've shown so far is assume the premises we've been given are true. Just 1 and 2 are the premises we are given. Assume all humans really are mortal. That's true. And assume Aristotle is a human. Then it follows that if Aristotle's human, then he's mortal. And we said he is human, so it follows that he's mortal. So we know there is one individual, at least one, but we know there's this specific individual from our domain of discourse that is mortal. And so we can infer that some being is mortal because we know this one is, so at least one is. So this will be our last line. If we know one is, then we know at least one is. Some being is mortal. Okay, so 4, notice this is another one where you only cite one line. And what will we call this rule? Well, here's the technical name. It's existential, because we're talking about an existential quantifier generalization. We're generalizing from a specific instance of a thing, in this case, a person, that has this property to something. Which thing we're not saying, just something has the property. So it's kind of generalizing in a certain way. Sometimes this is also called existential introduction, as in we didn't have an existential claim before and now we do. Existential introduction. And that is what we'll call it as a rule in the proof checker. EI, existential introduction. And that completes our proof. So let's take a look at what that would look like in our proof checker. Let's do a nice simple one together. Let's do a new proof in first order, not propositional. Here's premise number 1. Here's premise number 2. Separate with comma. And here is the conclusion. Set up my proof. First step, remove the quantifier. Change the bound variable to a term. Cite line 1, and remember all your rules are down here, universal instantiation or universal elimination. must be capitalized. You'll know it took it because it'll automatically replace what you wrote with the long name. Okay, now what are we doing? Modus ponens on lines 2 and 3. And now what are we doing? Trying to get this, right? So this is the new line. How do we move from what we have to this? Let's look at our rules. Existential instantiation. We didn't say that. We said existential generalization. Or in other words, we're introducing. I is for introduction. We didn't have them before, and now we do. EI. And we only cite one line for this because we're only looking at line 4 and applying the rule to that. So if we know 4 is true, then we must also know that line 5 is true by existential introduction. Let's check our proof. Congratulations, proof correct. Here's another one. I recommend that you pause, try it on your own, and then we'll do it together and run it through the proof checker. So let's get started. What do we have? What do we want? In the conclusion, I see that we have a main operator, existential, and then there's a conjunction inside of it. So we want an existential claim ultimately. And we now have a rule that allows us to get one if we don't already have one. Here are premises, we don't already have one. So I know I'm going to need to use existential introduction or existential generalization to get the conclusion. What will I need to have on a line in order to get this using that rule? I will need to have some claim about a specific object in the universe of discourse, replace X with something. I'm going to need to have M term, H term with the conjunction. If I have that, then I can use existential introduction. Oh, hey, look, conveniently, here's an MA and an HA, but it's not together on a line with a conjunction. So I have to do that first with my conjunction rule or adjunction or conjunction introduction. So I can do this and I'll cite lines 1 and 2, and I'll just start using this just to make it. We could call this conjunction still, it'll be just fine, but if you start using the proof checker, this is called, sorry, not E, introduction. We've introduced it. We didn't have it before, and now we do. We introduced it. But just for the record, this is also conj. Okay, now we have the thing we need in order to use existential generalization. So we'll basically just copy this. We're going to stick the quantifier out front and remove the terms and make them variables. And we'll cite line 3, not 2, but 3. And we could type out existential generalization, or we could just write existential introduction. I'll do the short one. Again, let's do some practice just using the proof checker, though feel free to skip ahead or pause and play with proof checkers on your own. Okay, so MAHA, here's our conclusion. New line, we started by making a conjunction. And then we applied existential generalization. I'm just going to copy the conclusion into the last line. Look down here. What is existential generalization? It's EI. Line 3, EI. Check, proof, done. Congratulations. So we looked at 2 examples. Now let's state the rule. Let beta be any term. Think of beta as anything that picks out some specific individual from the universe of discourse. So for example, a name is the simplest case of such a term. And for now, in chapters 13 and 14, I don't think you'll see anything other than names. Maybe I'm wrong about when things get introduced, but I don't think you'll see anything other than names. So you might just think, let beta refer to any name. If we have a statement that includes this term on a line, then we can add an existential quantifier to the front and replace all occurrences of beta, whatever the named object is, with a variable and write that on a new line. So basically, let's look at our old one, right? We had this on a line, we just rewrote it on a line, we removed the A's and replaced those with variables, and we stuck an existential quantifier out front. That's what this schematic is trying to illustrate. But again, if this looks all Greek to you, try to focus on the rule and maybe write down some examples that are a little easier for you to read than the ones in our meta language trying to talk about what you can do. Let's do one more together that uses both rules together, the universal quantifier and the existential quantifier rules. We have one that allows us to eliminate these and add these or introduce these. Pause, try it on your own, maybe try it in the proof checker. And then let's do it together. Okay, what are we seeing? I see that my conclusion is an existential statement. And so since there are no existential statements here, I know I'm going to need to use the existential introduction rule. What will I need to have? I'll need to have C where this is some name, essentially. I don't have C some name, so I'm going to need to get it. What else do I have? Okay, I know what I want. I want C with some name in it, and probably it's going to be A. But what do I have now? Let's pay attention to the main operators or quantifiers of what we have so we know which rules we can use. Okay, these are universally quantified statements. So the universal instantiation rule or universal elimination rule will allow me, is something that's relevant here. And this is just an atomic formula, so I'm not sure what I'll use here. And then perhaps these arrows will become relevant once I have removed this from out front. I'll get some formula with main operator arrow. So I'm looking like maybe eventually I'll get to use some modus ponens a couple times to get this on a line, then exit. So I've got a plan. Okay, let's get started. Let's just copy this on a new line. What do we do with existential instantiation? We remove this and we replace bound variables with a term. In this case, let's pick the same name we have in premise 3. And then we could immediately start doing some modus ponens here, but let's just get rid of these first. There's options for order here. Get rid of the universal quantifier, change the X's to A's. Now what can we do? We have main operator is now the arrow. So if you have a conditional, we do, and you have the antecedent of a conditional, you can apply modus ponens. And now we have the antecedent of this conditional, so we can apply modus ponens again. We're getting closer. Now that we have some formula with a name filled in, we can basically put that on a new line, remove the name and replace it with a variable and stick the existential out front. Okay, I've been lazy and I haven't put my justifications in. So let's make sure we know what those are. This was line 1, universal elimination or universal instantiation. This was line 2, same rule. What was this? This was lines 3 and 4. Modus ponens. And now we have lines 5 and 6. Modus ponens again. And from line 7, using existential generalization. we get to our conclusion. And again, each step embodies a valid inference. From knowing that everything in the domain is such that if it's an A, it's a B, then you know for any specific, if it's an A, it's a B. So likewise here, if you know everything in the domain is such that if it's a B, it's a C, then for some specific thing, if it's a B, it's a C. Okay, so we've established those things. Now we do know that, let's just, to not be stating letters, Aristotle is an A. And we know that if Aristotle's an A, then Aristotle's a B. Well, then it follows that Aristotle's a B. We also know that if he's a B, then he's a C. So it follows that he's a C. So if Aristotle's a C, then someone is, or some being is, depending on our universe of discourse. There's at least one, there's a specific one, then there's at least one. Okay. So that is showing the existential quantifier. And if you're interested, I'm going to run this through the proof checker, but feel free to end the video now if you do not want to watch me do it through the proof checker, and maybe you do it on your own. Or maybe you're not going to use the proof checker. It's fine by me. Okay, so we have 3 premises this time. And we have a conclusion. Something I wrote is not well formed. What is it? I don't have a clue. Premise 1. Oh, it's because I used the upside down A. It doesn't know what an upside down A is, apparently. So that's the problem. Isn't it? I do not have a clue what its problem is. Maybe it doesn't like A to be a predicate. Let's just try something simple to see if the problem is, does it like A as a predicate or not? It does not. It immediately interprets the capital letter A as a universal quantifier. So we cannot use A as a predicate. So in our previous one, let's just change all the A's to W's, because it doesn't matter what predicate, what letter we used. Okay, A's are all now W's. Let's put it in there like this. So it's got no problem with the upside down A. My first hypothesis was incorrect. Okay, so we have our proof set up. Start by removing some quantifiers. Oops, we didn't do it right. I removed the quantifiers, but then I didn't replace the bound variables with terms. So let us do that. Oops, I forgot to change one of the premises. Sometimes things are annoying, but precision matters in logic. All right, we did it. And just a reminder that all the things, like you can use just plain old E. I copied and pasted, but you can use plain old E for the existential, like when you enter it right here. Okay, that's the end of the tutorial for showing the existential quantifier using the existential generalization rule.